Howdy, and welcome to my video, where today I will be going over functions. So the basics of functions, definition, domain, um, restrictions, stuff like that. The problems I will be going over today will be from the virtual Math Learning Center. I will put a link to the problems in the description. All right. So let's start with question 1. Okay, so we have to determine if each equation represents y as a function of x. Remember that for this definition, right, for a function, every input has exactly one output. So for every x, there is only one y, and exactly one y value, right? So for a, right, you can rewrite this as y equals 4x plus 1. And you can probably see that every time you put an x value, you get one y value, right? So a is indeed a function. Now for b, we have x equals absolute value 2y minus 1. And with absolute value, right, we know that it gives us a plus minus. So this leads to x equals 2y minus 1 and x equals negative 2y minus 1. This means that for every 1x, right, we get potentially 2 values. But like we said, for a function, for every x value you get, you should only get one y. So b is not a function. For part C, we have 2x cubed plus y squared equals 4. We can move this 2x cubed to the other side by subtracting. So y squared equals negative 2x cubed plus 4. And now y equals plus minus square root negative 2x cubed plus 4. The restriction's not really important. The important part is that we have this plus minus, right? And plus minus means there are two outputs. There's y equal two different things, right? So for every x, we can have two outputs. So this is not a function. And for d, we have y cubed minus 4x equals 6. Add 4x, move it over, we get 4x plus 6. And when we take the cube root, there's no plus minus. So every time we put an x, we get one y value out, and we indeed do have a function. And that is the first problem. For the second problem, we have considers piecewise and find the following values. So h of negative 2, h of negative 1, and h of 2. So h of negative 2, and we look at a balance here. It's x is less than or equal to negative 1, and there's another one for x greater than 1. Okay. So first, we're going to look at our x value and say, what range is it within, right? Negative 2 is less than or equal to negative 1, so we'll use the first expression it gives us. So this will be negative 2 times negative 2. Negative 2 plus negative 2 plus 4 equals 4 plus 4, which is 8. Let me box my answers real quick for number 1. Okay, so for h of negative 1, right? Again, we'll look at our x value and see what expression do we use. Negative 1 is still less than or equal to negative 1, so we will keep using that one. Excuse me. So negative 2 times negative 1 plus 4 equals 2 plus 4 equals 6. Now h of 2 is not less than or equal to -1, so we check the next condition. Next condition is x greater than -1, which is true for 2. So we use the second expression. So we get 2 minus 2 squared, which is 0 squared, which is just 0. And that's question 2. So question 3 is to find the domain. Excuse me. Ooh. So by default, right, with no restriction, your range, your domain is unlimited, right? It goes from -infinity to infinity. But our restrictions tend to fall under 3 categories. Okay. First is denominator, right? So denominator equaling 0. Second one is value in radical being negative, so less than 0. A third one is argument in logarithm when base is positive is less than 0, right? Or actually less than or equal to 0. So we can look for these 3 potential restrictions and then rewrite our domain to include such restrictions. Okay. So first off, for part A, right, we don't have a fraction, we don't have a radical, and we don't have a logarithm. So this domain is just -infinity to infinity. All right. So for part B, we see that we have a radical, right? So for our restriction, right, this is restriction number 2. So we'll set the inside to the opposite, right? Because we want a domain, and domain is what we want, is when we want everything that could be valid, right? So the opposite of less than 0 is greater than or equal to 0. We get -3x greater than or equal to -4, and then we divide by -3, we flip the sign, and we get 4/3. It's our only restriction, so we do a number, our little number line, right? I'll do below. We have 4/3 right here, and it is open circle, closed circle from here all the way to the left. This means our range, our domain becomes -infinity to 4/3 inclusive. Okay. Now part C, we actually have a combination of 2 restrictions. It's 1 and 2. Right. So, excuse me. The radical, right? The x plus 4. So we know that x plus 4 has to be greater than or equal to 0, right? But the denominator says it can't be 0. And the only time the denominator can be 0, right, is when x plus 4 itself is 0. So because of denominator, x plus 4 equals 0 is restricted. So because of this restriction, we have to change the sign, right? We have to take out that equal, and we restrict it to just x plus 4 greater than 0. And we subtract 4 from both sides, and we get x greater than -4. And our range, our domain then becomes exclusive -4 to positive infinity. Also exclusive, of course. And for part D, right, we have a radical, but this is odd, right? So let me clarify for this one. A radical with even root. We have an odd root, and odd roots can have negatives, so this is perfectly fine. Our domain is then negative infinity to positive infinity. And that is question 3. Okay. Question 4, more domain. So you don't have to, for part A, right? You don't have to factor the numerator, because we're not solving, right? When you set this, if you ever set this equal to 0, it's like, oh, well, we'll solve, these gives you the solutions, and, these give you restrictions. But, this is expression, not an equation, right? So, solving for the numerator is nothing, because you actually don't know what it's supposed to equal to, right? So don't make the mistake of solving for the numerator. It gives you 0 information at all. The only thing we worry about, right, is our original 3 restrictions from up here, right, around over here. So we want to worry about this denominator. So we have x squared plus 2x minus 8. And I'll put equal to 0 so we can, you see that we can factor, right? 2 numbers multiply up to negative 8, add up to 2. That'll be positive 4, and negative 2. You're going to factor that to x squared minus 2x plus 4x minus 8. We get x minus 2 plus 4, x minus 2 equals 0. Then we get x plus 4, x minus 2 equals 0. And solutions to these is x equals 2 and x equals 4. But remember that these solutions, right, are for the denominator. That means these values are actually values that, invalid values, right? So we want to exclude them, and note that our restrictions, right, are the opposite of what makes it 0. So earlier, right, I would solve for the domain by using the opposite sign of restriction, but in this case, right, I am solving to get the restricted 0, right, the restriction, right? I want to see what values that makes the fraction invalid so that I can restrict them. Okay, and my x, so cannot be 2, and x cannot be 4. Okay, and our domain then becomes negative infinity to positive 2, union 2 comma 4, union 4 comma positive infinity. There you go. And then for part B, right, we have a combination of, the radical again, right, and the fact it's under the fraction part, so it's the denominator, right? So again, for 1 and 2, right, this is a variation where if you have a radical under the denominator, right, into even root, instead of doing x minus 7 greater than or equal to 0, you just take away this equal sign because of the fact it can't be 0. Okay. From here, you just solve, add 7 to both sides, x greater than 7. Your domain becomes 7 comma positive infinity. Okay. So this is my video on the basics of functions.